Hello, I'm Reed Graff, the student coach for Team 17682, TimberX, and this is...
I'm Phineas Burke, and I'll join him in this presentation.
And now we're going to present on programming and design. So this is going to be our second series where we're going to talk all about the basics of software engineering and everything you're going to need to know to be a good software engineer or to apply those skills directly to the FTC or FRC competition. So first and foremost, we're going to add these resources as, if you don't know already, there are actually a bunch of resources for high school students specifically, not only to get internships, but also to just learn code in general. So first and foremost, I love free code camp. This is how I led myself to becoming a software engineer and a self-starter. They have a bunch of free courses up to 300 hours long if you really wanted to. They've even got a YouTube series. Another really popular online course you can take is CS50 from Harvard. Some other high school internship that you can get is through this link right here from College Find. And all of these companies offer high school internships based in STEM. So Adobe, HP, LinkedIn, Discord, Google, Facebook, even the Secret Service, CIA, and FBI. Even Tesla and IBM and a lot of major tech companies. You have anything to say about that?
Nope.
All right. So what is a computer program? So a computer program is a collection of instructions that performs a specific task when executed by a computer. So really it's just using human commands and passing it to a computer in a way in which it can understand it. So the statement that says print hello world in Python is then processed by the computer and then returns the phrase hello, I'm Python on the next slide. So this is Python. The FTC Competition Act doesn't actually use Python, but we're just kind of getting a general overview to software engineering and computer programs. So what is a computer program? Activity 1. So what I want you to do now is open your computer, and if you're on Windows, you're going to do Windows R or search, and then enter CMD in the prompt and write echo hello world. So this is an example of a computer language. This is known as Bash. We're not actually going to be using this either, but once again, we just want to explain how easily and how accessible this software and these opportunities are. On Apple, you're going to hit GUI plus space and then do the same thing, except it's going to be called terminal. And Linux, if you use Linux, I'm already impressed, and I think you know what you're doing. But let's go ahead and do this on our own computer.
Also,
yeah.
Don't worry about if your thing is not green. If it's white, it'll work just as fine. That's just a preference that you can change.
Yep. So we can write echo and then hello world, and you print it, and as you can see on the next line, it says hello world. All right. So what actually is a computer language? So much like natural languages like English, French, Spanish, there's just different ways of communicating with computers. So a programming language is a formal language comprising of a set of strings that produce various kinds of machine code output. Just like in real-world languages like Spanish and English, they often work out very similar principles and can often apply to others. So for example, if you learn Spanish, you're maybe going to learn French even easier, or Latin even easier, or Greek even easier. The same thing goes with code. If you learn Java, you're able to learn Python and even database languages like SQL or SQL. For example, this is how you print hello world in JavaScript, or sorry, in Java rather, system.out.println and then hello world. In JavaScript, this is how you run it, console.log hello world. And then Python, this is how you're going to run it, print hello world. In the case of FTC though, we're going to be learning Java. So what actual software do we need? So first and foremost, we're going to need a text editor. So basically just Google Docs for coding, a way where we can write our code and edit it and actually to be able to collaborate with others. So another thing we're going to need is our actual language software, so something to give to the computer so that they can understand the code that we write. And then finally, or second to last, we're going to need an online storage where we actually collaborate with others. And then finally, we're going to need like an interfacing tool, so enabling the computer to interface with the hardware that we have. In this case, it would be the control hub for FTC. So first and foremost, the text editor that we recommend you use is Android Studio. You can visit this link right here or search Android Studio download. And this comes with Java already installed, so this already skips this step. We don't actually have to do this because Android Studio already comes with Java installed, so it's just really easy. And then in terms of an online storage, we recommend that you use Git, and you can download that right here. Just search Git, and then you can go to the download page. Online storage too. So Git is effectively just a way of communicating with GitHub, which is a cloud service similar to Google Drive, where you can just host your code and collaborate with others. It's one of the most common ones. I think it's like something like 98% of developers use GitHub as their version control system. You can visit this link or search it up and create an account and sign in if you don't already have an account. It's not necessary right now, but it's definitely necessary if you want to become a software engineer. So this is a quote that you'd like to say. Would you like to read out, Phoenix?
Programming isn't about what you know, it's about what you can figure out. And for me, this is very, I had struggled with programming because this was my first year ever like coding at all. And I didn't know anything, and I figured out a lot. So this is a very good quote that I like to go by.
Absolutely. So how do you actually make functional Java code? So let's get into that. So when you open Android Studio, it's going to look pretty messy, but don't worry. In order to actually open this first document, you have to click New in the top left. You have to open File and then New, and then you create a new Java file. And then with that, you're able to start writing all of your code. So you can see, you click File, and then New, scratch file, and then make it a Java file. And then in that, you're able to start actually programming and running Java code. So once you've written that code, this is just like an example of like a first test project. So you see, you don't need to worry too much about anything. Just know about this one line: system.out.println hello world. And then once we run that, as you see, this is going to be the output: hello world. And the way you actually run that in Android Studio is via clicking these green arrows right here, or the execute buttons. As you can see, it's printed the output over here. And then also, once again, as a note, is if you're ever going through this and you don't want to write all of this out, trust me, it gets painful as we get to bigger projects. The link to the code is always going to be right here in this hyperlink. So what is actually happening? So the first line declares a class, and the class is known as the class. Well, so effectively, these two words define a class, and then this is the class name right here. And then in this next line is kind of where Java begins processing this entire file. And effectively, it just looks in between these two curly brackets and runs everything in between them. So basically, all you really need to worry about is what's in between these two brackets, and everything else for the time being can remain the same. And that's kind of what you recommend. What we recommend you do, like visually, is kind of just block out these other two blocks because they're not important for you as a new developer. They're important as you get better and better, but for the time being, it's just going to be distracting, and you maybe don't fully understand it. So basically, keep everything within these two blocks the same, and just edit what's in between these two curly brackets. So that being said, what would actually the output with this be? Phoenix?
Well, it's essentially the same thing as hello world. It would literally just be Tim pouring.
Yep. And then how about the same thing here? We're just see TimberX robotic scheme on the next line.
You're just, changing the string of letters.
So here's another simple program that we can actually do. In this case, we're actually going to find a variable and then use that variable in the rest of the script. So as you can see right here, we're blocking out these two sections, and we're just worried about these three lines. So it's an int emt, and effectively what that's saying is we're initializing an int variable with the name emt, and then we're assigning emt to a value of 0. And then on the next line, we're system.out.println emt, and that's just going to print the value that we previously assigned it to. So in this case, it's just going to print 0 as the output. So now what's the output of this going to be?
Well, now it would be 5 because you're telling it to print the input.
Yep, and then how about now?
It would still be 5.
Yep, and then this is just another way of initializing variables. So you see on the previous slide, we used two different lines to initialize the variable. Well, we initialize the variable here, and then we set the value on the next line. However, we can do both those steps in one line here by saying int emt and then it's equal to 5, instead of just putting the semicolon. And then once again, we're just going to print emt, and in this case, it's going to be 5. So how about data type? So what if we try and print the value without assigning a value first? Or print the variable without assigning the value first. So as you can see, we initialize the emt variable, but we don't assign it a value. We just say int emt, and then we try and print it. We're actually going to run into an error in Java. This is our first error that we're going to talk about. And it's a variable emt may not have been initialized. It's not initializing a variable or assigning it a value. But we also get into math in Java. And this is, of course, going to be very important for FTC and programming in general, is actually doing math in Java. And in doing so, we're going to define two variables, both of them integer int variables, int1 and int2. The first, int1 is set the value of 10, and int2 is set the value of 5. And then these 5 lines, we're adding them, subtracting them, multiplying them, dividing them, and then doing modular division. What modular division is effectively gives the remainder after dividing. So in this case, the remainder of 10 after dividing 5 is 0. So as you can see, we have the outputs right here, 15, 5, 50, 2, and 0. So how about the common variable data types? So generally speaking, data types split into two different categories: primitive data types and reference data types. So primitive data types is just going to hold the value. So if it's a number value, it could just be 5. Or and in the case of it being a double, so data type that also contains decimals, it would be like 5.3265 or something to that effect. And then a Boolean just holds a 0 or 1, or just true or false. But reference data types are very different and they operate very differently. So we already experienced one of these using strings. So whenever we print like Hello World or print Tim Robotics Theme or TimberX, that's another type of data type called a reference data type. And effectively, the difference between them is that primitive data types only hold values, whereas reference data types hold values as well as different functions for that value. So we're going to get later on. We're going to get more into what we can do with strings and some other different reference data types. But that's going to end this video for now, and we'll see you in the next one.